everybody. My name is Neha and I'm a member of the Teen Advisory Board here at Howard County Library System. And today I will be going through stoichiometry. So before we begin with taking a look at the actual problems, it's important to have an overview and a good understanding of how we will approach these problems. So to begin, it's always important to write out your chemical equation and to make sure that it's balanced. You are then going to determine what you are given and what you want. After that, you are going to write down what you are given first and multiply it by a conversion factor, where the denominator has the same units as what you are given. And all of this will make sense in just a moment. You are going to keep adding conversion factors until the units of the last numerator is the same as what you want. And finally, you are going to check for your units and make sure your answer matches what the problem is asking for. So let's take a look at this chart right over here. This is a clever little chart that is very useful if you're a beginner or you just want to make sure that you're setting up your problems correctly. You can see right over here this starting step. This gives you an idea of how you will go about and approach a problem. This middle step shows you the main conversion factors we would think about when we want to convert between different units. And this final step shows you how you would end your problems and reach your final correct unit. So now let's take a look at a problem. We're going to start off fairly simple and build up to more challenging and longer problems. This first problem reads, convert 3.58 times 10 to the 24th atoms of Fe into moles of Fe. So let's think about this. This problem doesn't really have a chemical equation, but what we can do is determine what we are given and what we want. Well, if we take a look here, we see that we are given 3.58 times 10 to the 24th atoms of Fe. And what we want is to convert that value into moles of Fe. So right now we have determined what we are given and what we want. So the next step is to write out what we are given. And the reason for that is so we can begin to set up our conversion factors. So we know that 3.58 times 10 to the 24th atoms of Fe is what we are given, so that is what we are going to write. And it's a personal preference, you don't have to. I like to write that over 1 because it keeps everything neat and organized as we complete the problem. Now, the next step is we are going to have to determine what our conversion factor will be in order to convert the value into moles of Fe. Now, the step we talked about earlier was that whatever value you put right here, whatever unit you use, is going to have to match the numerator in your previous value. So we see that the unit we are using right here is atoms of Fe. So that means in our denominator right here, we are also going to have to use atoms of Fe. And you might ask, how do we know to put this value right here? Well, this is a standard value that we use whenever we talk about atoms. Whenever a problem asks about atoms or requires you to think about a conversion factor, we are always going to use 6.02 times 10 to the 23rd atoms of any molecule. And that's a standard number that we see all throughout chemistry. So now the next step is to determine what we will put in this numerator right over here. And the value we're going to put in the numerator is going to be based on the unit we want to end with. So in our problem, what we want are moles of Fe. So that's simply what we're going to put in our numerator. And we know it's 1 mole of Fe because we don't need to convert any further, and that will be the end of our problem. And an easy way to make sure that you're doing your problems correctly is to simply make sure that your units in the denominator and the numerator cancel out. So here, the atoms of Fe will cancel out with this atoms of Fe. So we know that we are doing this problem correctly. And if we solve this problem and multiply out, we get a value of 5.95 moles of Fe. Okay? So let's continue to another problem. This problem says, convert 2.25 moles of KNO3 into grams of NO3. So what are we referencing here? Well, we know what we are given, that is 2.25 moles of KNO3, and we want to convert it into grams of KNO3. So just the first step is going to be to write out what we are given, which is the 2.25 moles of KNO3, and just for organization purposes, I like to put it over 1. So the next step we have is to determine our conversion factor. Well, we see in the numerator, we had a unit of moles of KNO3, so we know that in our denominator, we're also going to have that same unit. And we know to put 1 because there isn't a standard molar value, and that's just to make sure that we are able to convert our moles into grams. So in the numerator, we know that we're going to have to put a grams value of the KNO3 because that is what we want to end with. And in order to understand how to get a grams value, we are going to have to calculate the molar mass of KNO3. And you can get these values from your periodic table. So we know the molar mass of K is 39.1 grams. We know the molar mass of N is 14 grams. And the molar mass of oxygen is 16. But since we have 3 of that 16, we are going to multiply 16 by 3 to get 48 grams. And then, in order to calculate the entire molar mass of KNO3, we are going to add all of that up, and we get 101.1 grams per mole. And that is our molar mass of KNO3. And now, we know that we have finished all of our setting up portion of this problem because our units cancel out. Our moles of KNO3 are going to cancel out with this mole of KNO3, and we are left with grams of KNO3, and that is what we want. That is what our question is asking for. So now, if we solve this out, we see that we have 227 grams of KNO3. So, again, it's fairly simple. You just need to make sure that your units cancel out and that you're setting up your conversions correctly. So in the next video, we will tackle another set of problems and continue practicing. I hope this video is helpful, and I hope to see you in the next one. Thank you!